Awesome. There we go.
So as designers and developers who create user interfaces, I think we've all either seen or imagined or been inspired by an experience that makes us go, firstly, wow, that's beautiful. I need to go build something like that. And then, depending on your level of tenacity, followed either immediately or eventually by, okay, wow, that's a bit ridiculous. How on earth do I even build that? And so I'm Soham.
And I'm Danielle.
And we're here to talk about how the Windows UI platform can help you craft such beautiful and engaging experiences for your Windows applications. And today, we'll mostly focus on some of the new capabilities that have been added or are being added to the visual layer and how you can easily use these to complement your existing XAML.
I'm sure you're familiar with the XAML framework, which provides styling, data binding, and so forth. And if you've done any custom drawing, you've used technologies such as Win2D, D2D, or D3D, which reside in the graphics layer. The visual layer, also known as Windows UI Composition, lives between these two and is where the building blocks for the Windows UI platform reside in the form of animations, filter effects, and elements of dimensionality. Now, from a technical perspective, these all run independent of your application's process, resulting in smooth 60 FPS animations and transitions and beautiful effects.
Now, if you've been to Paul Gasmarino's talk, What's New for Windows UX Developers, you've probably heard about all the new controls and patterns that are coming to XAML with this new wave of Fluent Design. But also, as creators, it's almost instinctive for us to want to differentiate. And so the Windows UI Composition APIs exist to empower innovators like you to go beyond what is already formalized or default in XAML. In fact, if you take a look at some of the most popular controls and patterns from the first wave of Fluent Design announced last year at Build, you'll see that these controls and patterns in XAML merely mark the maturation of capabilities that have existed in the Windows UI Composition APIs for a while.
So if I say acrylic material,
I'd say an effect graph with a background brush source.
reveal highlight,
I'd say composition lights with a scene lighting effect.
parallax,
Expression animations.
connected animations.
Keyframe animations apply to offset and scale. Or in other words, recipes and their constituent ingredients. And the composition APIs bring these ingredients to your Windows UI palette so you may construct your own recipes and craft those beautiful experiences incorporating elements of motion, depth, light, scale, and material in your existing XAML.
The fundamentals of the Fluent Design System exist as primitives in the visual layer, which are accessible to anyone using the XAML framework through several points of API interoperability. For instance, you can add reflectance to your UI, elements using XAML Light. You can create filter effects and materials to paint your XAML content using the XAML Composition brush. You can target your XAML properties with animations from the visual layer. And you can integrate any visual tree of content created using composition using Element Composition Preview. All of these interop points are mechanisms for complementing your existing XAML to add elements of dimensionality and are opportunities to craft differentiated experiences.
So speaking of differentiated experiences, let's jump into the first one that you've been wanting to talk about for a while. 2D animated vector graphics. Or in other words, collections of points, lines, curves, colors, and gradients that come together to create really beautiful experiences ranging from playful micro interactions to extremely complex and insightful data visualizations. So if you see these little animated icons on your screen, you should be familiar with this, and you're probably thinking, cute. And yes, they are. These are extremely playful, and motion, when used tastefully, really breathes life and fun into otherwise mundane tasks. However, this is more than just eye candy. This is actually really functional design, where these little geometries actually seem capable of understanding your user's hesitation or confusion when they encounter a new icon and responding back to them, communicating their function or their intent or why they exist through their motion. And now here, we see our friends at OneNote build upon the same set of ingredients to create a really cinematic and alluring onboarding or first-run experience for a new user. I gently let OneNote hold my hand and guide me through the landscape of this application that I'm about to discover. And it's hardly surprising that experiences like this cause engagement metrics and click-through rates to skyrocket, because it's really quite simple. as end users of any application, enterprise or consumer, we absolutely are drawn to beautiful and engaging experiences. Now, I don't know about you, but when I see this, I'm thinking those two things again. While that's beautiful, I wish we could build that today. And two, okay, wow, that's ridiculous. How on earth do I even build that? And when are your flights out of Seattle? Because how long is that going to take? How do I build that? Well, certainly not with videos or GIFs, because any kind of raster-based approach is simply a big no-go when you do some basic math. The total number of target resolutions across the full family of Windows devices and what this means for download size and memory consumption, and we're never shipping this. And let's add on to that some additional requirements. We want all of these animations to be extremely interactive and dynamic, by which I mean we want to tie the progress or the inertia of on-screen sequences and transitions to real-time input from the user. So we realize that what we need is an extremely highly optimized animated vector graphics API in the Windows UI composition APIs. So as of the April 2018 update that went live just a couple of weeks ago, we've now added a new visual type called shape visual, which would feel like just any other visual, but it allows you to create a lightweight tree of composition shapes. Now, these shapes are container shapes and sprite shapes, and if you've ever worked with the composition APIs before, this hierarchy should seem very familiar to you. Now, of course, there's support for animated geometry types, like lines, ellipses, rounded rectangles, and of course, our beloved paths. And for paths, we've added this interop mechanism so you can drop down to the Win2D or D2D APIs and harness the full power of those APIs to create your own path geometries, and then let the visual layers rendering and animation engine just handle the rest. Speaking of motion, we've added a new animation type called a path keyframe animation, which allows you to morph between any two composition paths that have the same number of control points. What this means is that you can now change the structure of your geometries over time. And of course, we've added support for trimming geometries. Now, this is a rather handy technique used by motion designers to draw or render only a portion of your geometry's total path length on the screen. And then not included in the April 2018 update, unfortunately, but coming to Insider Builds to you today is the ability to use any of these geometries as clips on your existing visuals. This allows you to clip or mask your UI and create really interesting transitions. So let's jump over and try to create one of these animatable geometries. So here I have the Van Arsdale app that you've probably seen from Paul Gasparino's talk or from the boot sessions. And I identify these preset icons as the region where I want to add some animated icons. So I go over to After Effects. Now, this is a file that I was handed by my designers, and they've added a bunch of these animations. So I play them in After Effects and see what it looks like. So we see that we have what I presume the first half to be a hover state for the mouse and a press state. So this is great. Now, I could try building this by hand. I'd set up a shape visual. I'd create some container shapes, some sprite shapes, and then I'd try to figure out the geometries. This is pretty straightforward, but just a little bit tedious. I mean, if you've ever worked with vector graphics before, you know that getting those Bezier segments just right is somewhat of a dark art, and I don't want to be trying out on stage right now. And if you work with motion, you probably know that getting those easing curves right is kind of similar. We'll have a lot of really good resources like samples and documentations for you to go check out how to create these things by hand, but I sort of want to spend our time today to address this problem at large, which is translating ideas for vector graphics from design to code is actually quite hard. And this isn't a unique problem to Windows. This is a problem that exists across the motion design industry on every single platform, especially for us at Microsoft internally. And of course, when we sought your feedback on these APIs, this was the one thing you outlined as a hurdle you wish didn't exist. In fact, wouldn't it be sweet if we could go from this static icon to this animated one with just a couple of lines of XAML like that. And
You got it?
sorry. Oops. And yes, indeed, it would. Only if my slides were to cooperate with me. So we are happy to announce that we're partnering with our friends at Airbnb to bring Lottie, a tool that you know and love, to Windows. I have to say, this thing kind of stole my thunder, but I'll live with that. So we're really excited to bring Lottie to Windows. And if you don't know what Lottie is an open source library by Airbnb that renders your After Effects vector animations natively on Android, iOS, web, and now Windows, with libraries for React Native and Xamarin. So what this means is that you design your animations in After Effects, or you start in Illustrator, move it into After Effects for motion. You then use Hernan Torrisi's amazing open source plugin called Body Movement to export this data out as a JSON. You then take this JSON and simply hand it to Lottie, and everything else should just work. For Windows, what we did was we took that data exported from After Effects and we translated it to a tree of composition shapes, composition animations, and brushes, and we surface it to you as a single custom framework element in XAML with playback capabilities. Now, what this means is that this is actually down to just a single line of XAML like the one on the slide. So we've really cut down on the resources required to move from idea or design to product or code. And let's jump in and take a look at Lottie. So here I have some files that I've already exported out as JSONs from Body Movement. And now all I need to do is reference these files as a source in my Lottie control, and everything should work. In fact, this is about as easy as any other media format, like a PNG or a GIF, but it's a lot better because the resolution is, the rendering is resolution independent. All the animations are smooth and 60 FPS, and of course, all of this happens outside your application's process because it's powered by the visual layers rendering and animation engine, and everything is dynamic and interactive. So all I need to do is include these in my project and compile one by one, and we can check it out. But that's kind of tedious. So we wrote this little utility tool that's going to be available in the store soon, which you can use to preview all your animations before you actually check it in. So here I have an icon, and as I drop it in, you'll notice something interesting happening. So this is sort of what we like to call Lottieception. We built a tool called Lottie, but we use Lottie to make it interactive. And as you drag it in, you see that the app gets excited about the JSON being dropped in, and as I move out, it's disappointed and calms down. But then when I drop it in, it's all excited again, and there you see this seemingly very complex vector animation rendering immediately with no additional work from you. And so this is one that you could say, imagine, is used for a hero moment in a photo capture app. And then here's a cool loader that lets, or a checkbox that lets your customers know that an event has finished completing. And then here's a really cool illustration that we got from our rewards team.
So this is great, but what if I don't work with a designer? And what if I don't use After Effects?
So if you don't use After Effects, you probably shouldn't worry, because Lottie is more than just a tool. Lottie is actually a community of designers and developers who are coming together to solve a problem that is industry-wide. So there are communities like lottiefiles.com where you can find thousands of open-sourced animations from thousands of designers with a lot of engagement. And so we went and pulled some of these from the internet to see what they look like. So here's just one I found, which is a cool little loader that you can add with no extra effort. Here's some really cool animated typography. Now, here's a sheep or a llama laughing at me because I guess that's what the internet's for. And here's a seemingly complex animation, which I guess you could use for a loading screen of someone actually riding their bicycle, which is cute, but also actually very technically complex. Speaking of things that are technically complex, here's an illustration from our friends at Xbox, where we're rendering an animation that that has over 500 After Effects layers, and this really results in over 1,000 composition shapes being crammed into a single shape visual. And we do this in a way that's completely resolution independent and smooth and buttery. So you can now see the power of the full composition APIs with a single drag and drop gesture. Now, you remember that OneNote animation that seemed like it would take forever to build? Wouldn't it be nice if you could just drag and drop and build that too? So let's see how that goes. So here you have it, that entire animation, which seemed like it would take forever, being rendered in just milliseconds. And of course, that additional requirement that it all be interactive, and it seemed like it was going to be crazy. Well, here you see me scrubbing through these frames. So of course, all of these animations are interactive, and I'm tying it up to scrubber progress, but you could tie this to any source of input whatsoever.
So Lottie works with JSON, but what if I want to use something other than JSON?
That's actually a great question, because when you reached out to us to talk to us about Lottie, you said that you were a bit skeptical about this approach that relied on JSON. And of course, if you're using Lottie for your cross-platform workflows to target multiple platforms, JSON's a great solution. But if for whatever reason you aren't comfortable with using JSON, since Lottie Windows is built upon the retain mode rendering and animation APIs from the composition layer, we can actually take this a step further. So here I have some of those icons that I wanted to include in the Van Arstel Lighting app, and we can see them all playing here. So let's see if we can do something that goes beyond JSON. So when I hit export or save, Lottie now gives me the option of saving this file as either a C#, a C++ CX, or a WinRT C++ auto-generated class that I can then simply reference from my XAML and have to do no additional work. So I'm going to save this as a C# file, and I'm going to head over to my app. So I'll stop it. And remember this guy that wasn't actually animated while all of its friends were? Well, let's give it some motion. So I comment out the static source, and I replace it with the Lottie control. And of course, here you see the URI source is a JSON file. And Danielle really didn't want to work with JSON. So we get rid of the JSON and simply reference that class that we auto-generated. Now, fingers crossed, this should just work. And what this really brings us is the ability to skip parsing your JSON files at runtime, which doesn't matter for simple animations like these icons, but for extremely complex scenes like the ones you saw from our friends at Xbox or our friends at OneNote, this really gives you blazingly fast performance by getting you directly to the closer to the metal APIs. And of course, all of this code is auto-generated and human-readable, which means that you can actually use any of this however you want. This is the class that I auto-generated. So you can pull out these shapes and use them in a context that's free of Lottie. So here's the Van Arstel app coming up. And if we did everything correctly, that poor default preset icon should also be animating. So here we have the other ones. And here's the preset icon, and it animates. Of course, if we configure our segments correctly, we should also have gotten the click part right. And let's try that out. There you go. So 2D animated vector graphics are a great way to add playfulness and a lot of functional design to your application. Sorry, why is this not progressing?
There we go.
Cool. These are a great way to add these playful animations to your application. And with tools like Lottie, adding visual polish becomes really easy. But vector graphics are authentically digital. Artistically, they're meant to be planar and exist in computing interfaces. But with Fluent Design, we're also rethinking how the planes in our UI on which content lives can be arranged spatially, and how we can add aspects of the physical environment that surrounds us and make your experiences more immersive, more engaging with things like depth, lighting, and shadows.
You've heard last year and this year how lighting and materials can be used to add additional meaning into your UI using familiar real-world concepts. They've manifested in APIs like Reveal and Acrylic, which draw users into your application content using scene concepts. Now, we're making it easier to include realistic depth and shadows to create more realistic, immersive UI. If you've been to some of the other Fluent talks during this conference, you've gotten a detailed overview on how scene-based shadows and depth can enhance your app. They provide a sense of hierarchy and can indicate relative importance or recency, and they keep users grounded in their existing context. Altogether, this means users can complete their tasks faster and more efficiently. This upcoming fall 2018 release, the concept of scene-based shadows and depth has been formalized into the Fluent Design System. You'll start seeing shadows and z-depth built into certain controls by default, which means users get more immersive UI without any app-specific work needed. In addition, the Theme Shadow XAML API, available in upcoming Insider builds, makes it easy to stand up complex shadow scenes and leave the details of scene management to the platform.
Wait, so these theme shadows, how are they different from composition drop shadows?
It's a great question. Let's walk through a comparison of them side by side. Great. So here we have two different stacks of visual content. And on the left-hand side, we have our drop shadow, which is a familiar flat shadow most of you have probably seen before. And it's associated with a single piece of UI content, like an image or a button. Here we have two of them. One is associated with the top visual, and the second drop shadow associated with the bottom visual. We've set the properties like blur radius, offset, and opacity to some arbitrary values in an attempt to mimic depth. On the right-hand side, we have our scene-based shadow model, and we have one scene stood up with the top and middle visuals as shadow casters, and the middle and bottom visuals as shadow receivers. For all of the visuals in this entire application, we've set the Z offset property, so all of them are positioned in Z space. But for the scene-based shadow, that's the only property we've had to touch. Because of the scene-based nature of this shadow, as you position it in Z space, the shadow adjusts the look and feel and position of the shadow based on the relative distance from the objects in the scene. Now, side by side and parallel to the screen like this, you may think they look similar enough. There are some small differences. You'll notice that in the scene-based shadow, due to the receiver-based nature, the shadow is clipped to the content of the receivers. You'll also notice the shadow cast from the top visual onto the middle and bottom visuals has a different look and feel. It appears closer, darker, and is positioned differently. So they seem similar enough side by side and parallel, but the differences in render behavior become very stark when we apply a transform, such as a rotation, to the visual holding the shadow. You'll notice the drop shadow moves with its associated visual at whatever offset we placed it, and appears to float in space. In contrast, the scene-based shadow on the right-hand side is rendered directly on top of the receiver's content, and the scene handles the configuration of the look and feel and the positioning. So instead of mimicking the appearance of depth using drop shadows, you can now easily stand up complex shadow scenes using the scene-based shadow model. You might imagine that the unique render behavior of the shadow on the right-hand side would lend it more naturally to experiences like mixed reality, where users can walk around your app and view it from different angles. Now, this is a great conceptual breakdown of the two shadows, but let's view a more concrete example of the new shadow in an app like the lighting app we just saw. So here we have the light app, and we have the shop open to the page with the grid of items for purchase. If we turn on our custom theme shadow experience, you'll see the shadows cast out, the grid items cast shadows onto the application background. And on hover, we animate the scale as well as the Z offset of each of these items. To create this effect, we are using an implicit light source placed above the objects in positive Z space. We have the application background as a shadow receiver, and we have each grid item as a shadow caster. Now, if we rotate this scene as well, you clearly see the Z space and translation I was mentioning. And you'll notice again that the shadow is rendered directly on top of the application background's content. Now, I mentioned we're animating these grid items. And to do that, we're animating the translation value of each UI element. And we're doing that directly off of the UI element using the animatable XAML properties. This means we can apply any fun composition animation we'd like. And so just to have fun and show how adaptive these shadows are, we went ahead and applied a spring animation to the same scene. And again, here, all we're doing is animating the translation value, which alters the Z depth of the object, and the shadow naturally responds automatically. Switch back to the slides. Perfect. So as mentioned before, you'll start seeing the shadows by default on certain controls. But if you want to create unique custom experiences like the one you just saw, it's very straightforward. All you need to do is first add the theme shadow as a grid resource, then bind the theme shadow to the shadow property of each grid view item, which effectively makes it a shadow caster. And finally, add the application background as a shadow receiver in code behind.
So I heard you mention this light. Where's this light now?
That's right. So you'll notice there's no light explicitly declared here because the theme shadow uses the default system light shared by the operating system and all apps using the theme shadow.
Wait. So you're telling me there's an implicit light source from the OS that lights up my content? Sweet. Do you know how much I love shadows? I want to put shadows on everything. Oh, by the way, acrylic, big fan. I want to stick that on every single surface I can find. And also, I have these sweet, giant 4K textures that I found the other day.
Wait. So that's great, but with great power comes at least a little responsibility. And that's the responsibility to tailor your design for your users' devices. You might tailor your design using design guidance available online. Or you might tailor your use of the APIs for performance. Speaking of which, you've asked for feedback on how you can ensure you're using the APIs in a performant manner. So let's take a quick look at Visual Studio and how we've made improvements to enable that. Awesome. So here we have the same light app running off of the newest version of Visual Studio available this week. You'll notice we have our runtime toolbar as usual, but there is a new heat map option with a selection of heat maps you can enable for your application. The redraw heat map shows regions of the screen redrawing frame over frame, and the overdraw heat map shows regions of the display that have overlapping visual content. And finally, the texture memory heat map shows a representation of the GPU memory used in your application. So if we enable this one, we notice there's a lot lighting up here, but it is expected because each of the images are in fact backed by a texture in GPU memory. However, this is lighting up a little bit more than we might expect. Currently, we have the heat map enabled for the entire app, but we can go ahead and use the select tool to scope it down to the region we care about. Here we notice this image is actually quite a bit bigger than the images next to it. It looks like we may have accidentally loaded the full resolution image instead of the smaller image, which would be just fine for this smaller grid experience. We could go ahead and kill the app, rebuild it, kill the app, resize the asset, and rebuild it. And the heat map would shrink to indicate that the texture, the memory used by the application has decreased for that image. However, in the interest of time, we'd like to encourage you to try this out for yourself. But Soham, we digress.
So while your application's UI should be tailored for the wide range of Windows devices, we, with Fluent, also believe that your users' experiences should be continuous and seamless across Windows. And with Fluent Design, we are creating a system that not only feels natural and immersive on each device, but also a system that dissolves the boundaries between 2D and 3D computing environments. As mixed reality becomes more pervasive, as you've seen at the keynote, we've shown you some investments we're making to bring aspects of scene-based rendering using light, depth, and material to your UI. But we're also making investments to reimagine how the content or the objects that are central to your application's experience are represented in digital environments. Now, you can imagine scenarios from education to retail, from manufacturing to entertainment, from customer support to the arts, where a richer, more dynamic, and a lifelike digital representation or 3D volumetric content allows your applications to be much more productive, capable, and of course, magical. Now, as 2D UI creators, as app creators, it's been difficult to create these experiences because of a number of reasons, chief among which being that 3D rendering and animations are hard. These seem like an esoteric technology used by video games or special effects, and it almost always means that you need to go learn a new technology stack. But in the visual layer, it is our guiding principle to take difficult design ideas and make it easily accessible to 2D application developers like yourselves. So we're making early investments to make the use of 3D volumetric content very easy in your XAML. Now, if you remember those objects from the lighting app, the objects that were the center of the experience, the lamps themselves, were really images. We did use composition lights and composition effects to create the illusion of materials and of real worldness, but the moment you try interacting with those images, that illusion falls apart. So I think we can do a little better. So I'm going to go back to that app and I'm going to try and make some experiences to improve it. So for example, I was a user of this application and I was trying to shop for lights or lamps. And what if I wanted to actually play around with that lamp as if I were in a store? I could turn it around and look at its different parts, get a feel for how it's built, its materials, its texture. Now, let's let our creativity run amok. What if I actually wanted to preview that lamp in my own room, in my living space? What if I wasn't just satisfied by paying $399 for one of those lamps? I actually demanded that I get a copy of it for my Cliff House and VR space. And what if I could get a handy interactive model to help me put that shipment together instead of those horrible paper pamphlets that we have to deal with today? Now, that's a lot of what ifs for a 300-level talk. So for my atonement, I'm going to jump over to Visual Studio. So here I have that same lamp control, and I've ripped out its guts and replaced it with an experimental API that we are working on. So if you see this API, this should look like any other visual you've ever used before. We call it Spatial Visual, and it still has the same properties as any other visual, except I have this thing where I load a spatial model. Now this is loading a GLTF file, the same file format that's used by creation tools like Paint 3D or applications like Office and Mixed Reality Viewer, and even printing tools like 3D Builder. And I load it as simply as I would an image. If you work with a surface brush, this method is almost identical. Then I simply create this little visual tree, add it to my XAML control, and then I simply configure some basic manipulations and transforms using the composition APIs that you are familiar working with. Now, if I've done everything correctly, we should have a 3D model in your app. Now, you're probably thinking, so what? Like, this looks just like the image before it. Well, what if it were dynamic? And then as I rotate it, I get to see more about this model. I get to see its specular behaviors, and I really get a feel for what this object's like. In fact, when I looked at it from the sideways view, I just thought it was some quirky looking lamp. But now I realize that this is actually Seattle's official mascot. If you haven't brushed up on your organic chemistry before build, this is a caffeine molecule. And so I'm not going to buy this lamp because I absolutely hate coffee. But what if we tried doing a little more? These lamps are rigid bodies. But in the visual layer, we really want to bring those lifelike motions to your 2D applications. So I'm going to do a technical preview of a quote-unquote lamp. Now, if you're actually a lamp retailer, I highly discourage you from selling one of these. So this is a full-blown 3D model with complex skeletal and mesh animations all being animated and rendered by the visual layer with very little extra work from you. This seems just like the visuals that you know and use, but this really lights up a new kind of an evolved visual language that allows your users to understand and communicate in ways that go beyond traditional media formats like images or videos. And of course, this is extremely functional, but this is also for fun. So you've heard about these mixed reality experiences that are meant to be continuous across windows. And we believe that for continuity, mixed reality devices like HoloLens or VR headsets really require traditional 2D form factors to also complement and complete these experiences. And so your applications, your existing Windows applications, play a really important part in this story. And so we are working really hard to bring this kind of 3D content to you in XAML as easily as using any other traditional media format like images or videos or GIFs. And so some of the capabilities that we're exploring are the ability to load or author these 3D models very simply, construct basic spatial scenes, and of course configure animations and dynamic interactions. However, as I said, all of this is really early thinking and nothing set in stone. This isn't actually available in the insider builds today, but will be after the autumn update, which means that it's a great opportunity for you to come collaborate with us to tell us how you want these capabilities to solve your business problems and how you want to bring these to your applications. So I'd recommend that you reach out to us at aka.ms/WAC, Windows UI WAC 3D in 2D, and give us your feedback.
So we've covered animated vector graphics, we've talked about scene-based shadows, and we've done a sneak peek of volumetric content. But we haven't touched on materials and lighting, or this other thing I mentioned earlier called the iAnimation object, which allows you to animate the XAML properties off of the UI element itself. If you did want to learn more about lighting and materials, last year's talk by Lindsay and Kelly did a great rundown of how these can be impactful in your application. And in fact, the centerpiece of the light app we've been using was created using the material creator they introduced last year.
And of course, when we started this talk, we started with the promise that we wanted to help you bring all of these experiences to your existing Windows applications, which is to say, if you've been following the announcements at the keynote about UWP XAML host, all of these engaging and beautiful experiences built using the Windows UI platform are accessible to you in your existing Win32, WPF, and WinForms applications. So as a quick demonstration, in the interest of time, I'm going to switch in here and show you yet another truly horrible lamp. And in this case, you can imagine the application has a WPF control on the left, that's what it is, and there's a list, and the data is bound to a XAML control on the right with full-blown 3D rendering, and we have a rhinoceros doing this dramatic slow-motion run at us. And if you don't believe me, I configured that Spatial Visual to have a 30-degree rotation angle so it wasn't charging at us head-on. So now that we've proven some of these ideas to you and shown how you can bring these capabilities to your existing applications, we do want to reiterate the fact that the promise isn't just your Windows applications, it really is your applications. That is to say, we really care about your feedback. All of the things that we've spoken about today, from modern UI in your desktop apps to animated vector graphics with support for tooling like Lottie, better XAML integration for shadows, and of course, more insight into how these APIs affect your users' devices and performance tuning. All of these were based on feedback that you provided us at Build last year. In fact, even the iAnimation object that we didn't cover was something that you've asked for, and it's going to be available in Insider Builds today. So here are all the things that we've spoken about, And we hope that you can come talk with us, join us in our conversation, and help us figure out where we should invest next.
So here are some areas we're thinking of investing in next, and we'd love to hear your feedback on these. We've talked about initial investments in enabling you to add volumetric content to your UI, but we're also prototyping what volumetric UI itself might look like. We're also looking into stereoscopic rendering to bring depth to your 2D applications in mixed reality. And we're investigating a text primitive with optical scaling and what that might look like with full integration into the composition engine.
And of course, we aren't done with shapes because we want to bring these animated vector graphics to the XAML shapes that you know and love. So we can actually tackle at-scale problems like data visualization that require framework benefits like hit testing or data binding and accessibility and so on.
So this is all based on your feedback, and those are some areas we're investing in, which are all based on that. And so thank you so much for your continuing input and support. Please know we personally do see and respond to all of the messages you send us, so we encourage you to follow us on Twitter for the latest updates, clone our sample gallery to see how to use these APIs, and interact with us on the issues section, and shoot us an email for any questions or feedback.
And of course, for Lottie, I did say we'd cover this at the end, so we are bringing Lottie at the URL mentioned. It's just been held back a little bit, and you can hold me personally accountable. This is going to be available really soon to you on GitHub.
And finally, there have been a number of breakout and theater sessions related to Fluent during this conference. So if you've missed them, feel free to check back online later to see the recordings.
Thank you for your time, and we'll stick around for any questions if you have any. Please feel free to stop by our booth, and our friends at Fluent want to say that we have some Fluent swag outside the door, so feel free to collect it on the way out.